Hi everybody, today's lesson is all about right triangle trigonometry. And you guys can go ahead and write down the definition that I have provided you for trigonometry, which is just the study of the relationships between the angles and lengths of a triangle. So we're focusing on angles and lengths and seeing how they relate to each other. So when we talk about basic trig functions, we use the idea of an angle. So we use theta, it's a Greek letter, to mark an angle, but it could be x, it could be any variable. It's just a variable that represents an angle. So when we're talking about the relationships between angles and sides, we're basically going to say our starting point is this angle, and we have to define the rest of the sides in the triangle. There are three types of sides. Well, one that is probably familiar to you is hypotenuse. And that's always across from the right angle, that 90-degree angle, that's the hypotenuse. The other two terms that we use are adjacent and opposite. Well, opposite is truly on the opposite side of the triangle from your angle. So it just depends on what angle you're looking at. So these can change, okay? So you have to be paying attention. So over here we have opposite. And next to, which is what adjacent means, right next to your angle is your adjacent side. So once you figure out where your angle is, in this case we're at the bottom right, could be up here, but right now we're down here, you have to be able to label these sides because you have to figure out what the trig function is. So sine is, well, we write sine as sine of theta, right? You have to take the sine of an angle, and we evaluate it, or we abbreviate it sin, and it's going to equal opposite over hypotenuse because these are going to be numbers, so it's going to be a fraction. Okay, so cosine we abbreviate as cos theta, but we always say cosine, and that is going to be adjacent over hypotenuse. And tangent, we just abbreviated as tan, which is obvious. That is going to be opposite over adjacent. And we have a little saying that helps us with this, okay? So we remember TOA. And you maybe write this a little bit differently depending on how your previous teacher has told you to do that. However you write it is fine, as long as you remember it. So there are also some reciprocal functions. So we have cosecant, secant, and cotangent. There are 6 trig functions in total. We abbreviate cosecant as CSC, and that is always the reciprocal of sine. So that's going to be hypotenuse over opposite, right? Just the reciprocal of this fraction. Secant, which we evaluate secant theta, when we need to evaluate it, we write SEC, and that is always the reciprocal of cosine. So that's hypotenuse over adjacent, and cotangent is adjacent over opposite. Just the reciprocal of the fraction of tangent. So when we get into reciprocal functions, the definitions, these are what I just went over. They are reciprocal. So cosecant is 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta. Now sometimes people get confused because I'm putting 1 over. Well, let's think about what that means and why that is what it is. So I'm going to give you an example over here with just some numbers. Well, if I said the reciprocal of 1/2, you would say 2. And why is that? Because we've told you in the past you just have to flip the fraction. Well, the reason is because you're doing 1 over 1/2, just like I did here, 1 over sine. But in the end, I'm just going to multiply by the reciprocal, right? I'm not going to divide by 1/2. I'm going to multiply by 2, which is 2. So that's why this works. It's 1 over sine, but if you have a fraction, remember the reciprocal is just to flip it around. Okay, So then I need to evaluate the 6 trig functions. So this is something that you have to know. You have to know what the trig functions are and how to find them. So first things first, the angle that we're starting with is up here. But I need all 3 sides. So shoot, I got to find the other one. So we'll label it x for now. So this is a right triangle. So I get to use the Pythagorean theorem. So x squared plus 12 squared equals 13 squared. So I get x squared plus 144 equals 169. So x squared equals 25. So x equals technically plus or minus, but since we're looking at length, we only care about the positive. So my third side here is 5, and I need that. I also need to label what sides they are. So if theta's here, I should know that 13 is the hypotenuse because it's across from 90. Opposite would be 5 because it's opposite of theta. And 12 is right next to it, so that's adjacent. So when you come up with the trig functions, you're just going to list them. So sine theta, cosine theta, tangent theta. And again, you have to know these. Cosecant, secant, and cotangent, which we just covered a couple minutes ago. So again, you may want to write it down a few times, but this whole lesson we're using SOH. Okay, and this means that sine is opposite over hypotenuse. So sine theta, opposite is 5 over hypotenuse is 13. Okay, and then cosine is adjacent over hypotenuse. That's what A and H mean. So adjacent is 12 over the hypotenuse is 13. And tangent, TOA, OA, is opposite, which is 5, over adjacent, which is 12. Okay, so once I find these 3, it's very easy to find the other 3. Okay, I just need to use the reciprocal. So the reciprocal of 5 over 13 is 13 over 5. The reciprocal of 12 over 13 is 13 over 12. And then 12 over 5. So that's how you find the 6 trig functions. Okay? So let's do number 2. Again, here's theta. That's where you're starting. Label your sides. I've got opposite and hypotenuse. Remember, your hypotenuse is always across from the 90. And opposite is opposite your angle. So I still need that adjacent side. So I'm going to go x squared plus 9 squared equals 25 squared. Okay, you may need your calculator. So I'm going to do 25 squared minus 9 squared, which gives me 544. And, well, take the square root of 544 is not a nice whole number. So we do need to reduce this, though. So this is going to be 16 times 34. So x is going to be 4 times the square root of 34. You need to reduce all radicals, okay? That's very important. So when you find the 6 trig functions, sine theta, cosine theta, tangent theta, cosecant, secant, and cotangent, you need to not only reduce all your fractions, but also rationalize any denominators. So what I mean by that, sine, again, is opposite over hypotenuse, so 9 over 25. Cosine is going to be adjacent, so 4 root 34 over 25. And tangent is going to be opposite over adjacent, which is 9 over 4 times the square root of 34. Okay, however, we need to rationalize this. Remember, no radicals in the denominator. So I need to multiply top and bottom by square root 34. So that is 9 root 34 over 136. Alrighty? Always rationalize. Then you need to find the reciprocals. So cosecant is always the reciprocal of sine. So 25 over 9. 25 over 4 root 34. And I want you to rationalize this one on your own in just a second. And then tangent, I would always go back to the beginning because I just rationalized this, but I don't want to do it again. If I go back to my original fraction, it's going to be 4 root 34 over 9. Okay, you'll get the same answer if you reduce this one or reciprocal this one, but it just takes longer. So go back to the original. So right now I want you to pause the video and I want you to rationalize secant of theta. Okay, you should have gotten 25 root 34 over 136. Okay, so make sure you know how to rationalize your denominators. Okay, so then another piece of today is to use your calculator. So you first need to make sure that you're in degree mode. So go to mode, make sure it's in degree, and you're just going to type in sine of 25. Wonderful, 0.4226. Okay, cosine and tangent are the same. Cosine 45, we got 0.7071, and tangent of 99, which is negative 6.314. Okay, so those are very straightforward. However, with cosecant, your calculator doesn't know that. Okay, so you have to remember that the reciprocal is 1 over sine of 6 degrees. Okay, remember those reciprocal identities? So you have to type in 1 divided by the sine of 6 degrees. Okay, and you get 9.5668. Cotangent, again, is the reciprocal of tangent. So 1 over tangent of 11 is 5.1446, and then secant is the reciprocal of cosine. And again, remember, you have to remember those reciprocals. So 1 divided by the cosine of 27. And again, this is the only way you can type this in your calculator. You get 1.1223. Okay. So the last piece of math that we're going to do today is to solve triangles. So when you label triangles, you always label capital letters for your angles and lowercase letters for your sides. And opposite sides should have the same letter, except for the angle is capital and the side is lowercase. So let's label this triangle. B is 24 degrees and A is 8. And I need to find all missing angles and all missing sides. So you're going to need to use trig. But there are a couple of other things that we get to use because we're smart and we remember things that we've learned in math before. So if you remember that angles within a triangle add up to 180, I can find angle A. It's 180 minus 90 minus 24. Okay? And you're going to just do that in your calculator, and you get 66 degrees. However, I always like to use my given information. So B is going to be my angle. Then they gave me my adjacent side, and you have to figure out which one that you want to find. Well, you'll decide, but maybe we'll find the hypotenuse. So you have to write the trig function that represents this. So A and H, again, don't forget your TOA, is cosine, right? AH is cosine. So I can say that the cosine of 24 equals 8 over C. Okay, I'm coming up with the equation to help me solve it. So again, when you have a variable in the denominator, we got to multiply by it. So C cosine 24 equals 8. Divide both sides by the cosine of 24. You do this right in your calculator. 8 divided by the cosine of 24 is 8.757. And we know what A is. So then the last piece that we need to find is B. Well, you could use trig again, or you have 2 of 3 sides of a right triangle, so you can use Pythagorean theorem. So it's going to be 8 squared plus B squared equals 8.757 squared. And then you're going to solve for B. And you get B equals 3.562. 2. So that's how you solve for all the missing sides. So we'll go try part B, and we'll talk about it the next time we meet. See you then.